Hello everyone. In our last tutorial we have discussed about Equatable protocol, the use cases of Equatable protocol using which we can make finding a custom object in the so technically Equatable helps in comparing custom class objects and finding them in a collection. So that's what we discussed, where if we don't use the Equatable protocol, we need to go with where classes. If not, see contains also. See, this we discussed. If it is if this address is not conforming to the Equatable protocol, then we cannot find an object in a list. Of course we need to go with the where class, not only contains with the first index or anything, but if finding an object gets very easy if that particular custom object conforms to the Equatable protocol. Why? Because here we define it, and if it is a structure, default synthesizers will be there, so we don't need to implement it. Whereas as it is class, so we need to implement it, and we need to mention if both objects needs to be equal, what is the condition. So this is Equatable pretty much, and this is for finding. Okay, so it is for search or find. It helps, it gives an excellent API, so that you don't need to use the where classes. There is another protocol in this video we'll discuss, which is comparable protocol, which is pretty much helps in comparing and sorting custom objects. That means we know that Equatable is basically for this. So comparable is for less than, greater than, less than or equal to, greater than or equal to, and comparable, if you can see, it is gets extended from Equatable. Actually, when something is getting conforming to the comparable, that means it has to conform to Equatable as well. Then only these two we can handle: equal to, greater, less than or equal to, greater than or equal to. So that's what it is. Comparable protocol helps in comparing and sorting custom class objects, and this less than or equal to and greater than or equal to use Equatable stuff, as comparable protocols extends from the Equatable protocol. So let's discuss this with an example. Now let's say I have a structure called employee. Now I have created 3 instances of the employee. I have taken that in a list. Now I want to sort it. So if I try to sort it, so all it is saying is sort by using something or something like that. But let's see what it is giving, the what output it is giving. Okay, let me run it and show it, where it's saying like on, it clearly saying like referencing instance method sorted on sequence, which is a sequence, persons list is a sequence, requires that employee conform to the comparable protocol, then only you can sort it. Otherwise how can we sort it? Sort is either in the ascending order. Sort, if I say sort, it is either ascending order or descending order, correct, or descending order or the ascending order. For that it needs, this sorted method needs some information, but this information is not available here, correct. So especially sorted, or when we are comparing, or if I have to compare, like if person 1 greater than person 2, then I want to give, like, let's say person 1 is greater than person 2. So same, let's see if it gives an error, or so same, binary operator greater than cannot be applied to 2 employee operands. Why? Because this you cannot apply it now, like earlier, even this also. Why? Because we need to do comparable. Now as it is structure, okay, now we need to define comparison. So comparison is, let's say LHS dot age greater than RHS dot age. That means then I can say like, okay, based on the age I want to go with it. Okay, now let's see if it is giving the results, or it is still, I think it's in a good shape as it is. Let me print so that we can see the result. So obviously person 1 is greater than person 2. Why? Because person 1 age is 25, person 2 age is, sorry, did I write it the other way? RH is yes dot if person 1 greater than person 1 is greater than person 2, this shouldn't be coming. And if I say sorted, okay, 30, 25, 30, so Bob has come first. This is working fine sorted, but this is having some issue. So this is like person 1 greater than person 2. Okay, this sorted is working fine, which is good. All these are sorted based on the age, but when I say person is greater than person 2, or maybe I need to do something like this, person 2 is less than person 1, or person 1 is less than person 2. Why? Because we're having this operator here. Let's just dot range less than person 1 dot less, else the reverse order. Person 1 is person, here person 2, here person 1. So exactly we write the opposite statement here, person 1, person 2. Okay, person 2 is greater than person 1. I think now it's working. Person, so as it is this, I think I can only give this less than operator. So person 1 age 25, person 2 is 30, so person 2 is greater than, is elder, correct? Person 1 is elder, so it's based on this it's going. Okay, person 2 is elder than person 1, person 2 is elder than person 1. Now what, for example, as it is structure, see, that's basically the use of comparable operator. For example, if you need to do less than or equal to, or else if person, okay, or let's say if both are like 30 years, if for example, I mean technically these two are same. So if I see like if person 2 less than or equal to person 3, actually person 2 is less than or equal to, it's not less than but it is equal to. Now person 2 and person 1 and person 3 are of same age, right? Are of same age. Okay, now let's see whether less than or equal to is working or not. Okay, person 2 and person 3 are of same age. Why? Because this and this. So we have defined only less than. How come this equal to is working? Why? Because as we discussed, equatable stuff, this greater than or equal to or less than or equal to uses equatable stuff, as comparable protocol extends from equatable protocol. So as it is structure, we having automatic synthesizers, but if you say class, it will start complaining, saying employee cannot be constructed because it has no accessible. Okay, class employee has no initialize. Let me say these, let me take these being the initializers. Now it should not complain. Now it is saying type employee does not conform to the equatable. Why? Because it's a class. Okay, so as it is complaining, let me quickly write the initializers. So parameter name string comma age int, self dot name is equal to name, self dot age is equal to age. Okay, we need to, as it is class, we need to give the equatable. So it is LHS dot age is equal to RHS. So this we need to do if it is a class. Why? Because automatic synthesizers will not work for classes. Okay, yeah, this synthesizers will not work for classes. We need to explicitly define the equality function as well. So now I think everything will be normal, and of course person 2 is elder than person 1, and person 2 and person 3 are of same age, correct? So sorted dot description, let's say. So let's see if it prints. Okay, it's not printing, that's fine, but that's how the comparable object is very useful when you are sorting something or something like that. But let's see if the greater than works. I'm just trying this. So no, it always is less than. I just tried just to showcase, like it's always less than. Okay, now let's see if we can apply greater than. That means if person 3 is greater than person 1, print so it's basically same, person 3 is elder than person 1. Let's see if it's working or not. So person 3 is elder than person 1, correct, is elder than person 1. But whereas if I say person 1 and person 3, now let's see what it is printing it. So it should not print this thing, correct? So it's wrong. So basically that's what comparable protocol. It just the summary is it conforms to the equatable first, and then so that is the reason less than or equal to, greater than or equal to can be, we can use them as well, and less than and greater than for comparison. Especially this is used in comparing like this. Especially this is used in comparing and sorting. Okay, for sorting. Otherwise, if it is custom objects, why? Because if there are default objects, let's say let str is equal to iOS and let str1 is equal to solves, let's say. Okay, this is a string and this is a string. Now you can, if str greater than str, you can write this. Why? Because these are primitive types, correct? So it checks the alphabetical order and takes care of. Why? Because these are primitive types. Automatically they have okay, yes. Why? Because a b c d e f g h I, yes. So initially it compared and it is giving yes. For example this is apple. Now if I run this, yes. Why? Because str, of course it is greater. For example, okay, this is apple and this is banana. Str, okay, let me banana apple. Okay, now let's see. Str is equal to banana apple. So based on the alphabetical order, this it is starting with A. Maybe it is checking in the alphabetical order first B, then A should come first. Actually str is greater than str1 actually. Okay, let's see how it is doing it. Apple apron, let's say 5. No, why? Because str is greater than str. No, why? Because here it is a b c d e f g h I j k l m n o p p. Okay, let's do this fashion then. str1 less than str. Actually alphabetically this is of str1. Oh, maybe the next one it is taking, this is of higher. Okay, whatever it is. So it's basically it is basically taking this r is this pqr. This is less, this is more, correct? After p r comes. So that's how it is taken. So these are primitive types. Comparable and equatable automatically applies to here. For example, let's say val1 is equal to 20.0. let val2 is equal to 20.05, let's say. Now 20.00. So now if I write the same condition, I don't need these, doesn't need any comparable or equatable protocol. Why? Because these are primitive types, integer, double, strings, so these don't need any comparable or equatable conformance. These are straightforward. And let me comment out this, and if I run this, it's yes, val1 less than val2, it's 20.00. so that's how the basically for the comparison, these are primitive types, it's fine. But what about if it is a custom type like employee? Then we need to implement it to the comparable protocol. If it is a structure, you don't need to define this. If it is a class, you need to define this as well. Now you can do employee 1 greater than employee 2 comparison you can do. And if you have a list of employees, the sequence you can sort it, correct? So basically if you want to sort it by their age or their by ID or their by salary or something like that, this comparable object is of very useful, and this comes from the equatable. Okay, I hope this post is useful. Thank you.